There are basically two things that I kind of have in mind as next steps to play with this, because they're so I was in the last video struggling with the intuition about like the intuition of the swaps in here. Again, the intuition of the swaps in here is easy in the sense that it kind of feeds the mental model of, you know, you've got like the expected input for this is a basically you know, one number, right? So here you just got like an animation that's based on time, and so based on this number, right, you want to kind of activate a set of rotations, which will just making me dizzy, which will just give you the desired result, right? Because if you, for example, want a 1, right, what you want to do here is of course, you want to still apply all the Hadamard's because you want to create that superposition, but then you only want to have that one set of rotations in here that generates that pattern, which is basically just one counterclockwise round around the face until here, right? So it's like it's just one circle. You know, the notion being that the somewhere here in the middle, which is kind of represented by, you know, this one being swapped into this one, because if you that's literally sort of like half the way of your resolution. This is where you want the whole thing to kind of mirror itself, right? And then you also have the biggest rotation. Yeah. So, but I could imagine, like, even if it's not like even if it's not something that's like super intuitive, it should be actually, but if not, it's something you can fairly figure out by trial and error. Say you're trying to build this yourself. Here is a bit more complicated, right? Because here we're talking about like the ideal input is not a number, but it's actually a phase encoded wave, right? And the way I do this quickly is actually we'll just use the same one. So I'll just put a 1 and then I'll just put the QFT. Here. So that's my input. Maybe I'll put some separators as I have before in my other videos, just so it's clear that this is the input, and exactly everything that's, you know, before everything that's here is just the input, and then this is the actual QFT. Now this is a bit less intuitive because it's yeah, you can think of, you know, at the end of the day it's the inverse of this implementation. So, you know, just by definition, the way you do the inverse is you kind of walk your way backwards. So then your intuition is, you know, yeah, you gotta do them because you gotta do them, because you gotta uncompute them. But I'm not super happy with that. I want to try to see if there's something else that one can use mentally to justify the need of the swap. So there's two things that I wanted to explore in maybe this video, and I don't know if another one. But it's one is the idea of, is there any other way to build that without the swaps? Which, you know, there's plenty of people smarter than me out there that have probably figured out that's the best way to do it, but who knows? I don't know. Maybe that's gonna give me help me uncover some insights. And another thing is, I was just thinking now, right before I started recording, that, you know, at the end of the day, if the you know, while playing with Grover's algorithm, I kind of learned that trying to take a look at certain operations from another perspective definitely helps to gain insights, and in that particular case it really helped me to look at the whole thing from a pure interference perspective, as in being, you know, when you apply the oracle, you're applying a phasing, right? And so that phasing can be interpreted as, you know, so the computer science way, you'd say, you know, also the high level way, you would say, yeah, this is just a phase rotation, so you just rotate these things here. But if you look at it from an interference perspective, it's like, okay, so how are you going to do that? So at the end of the day, it's everything about interference, right? So the way you do it is, you add that, you kind of think about the mathematical model. It's like that would be the equivalent of adding, some positive, I'm lacking the vocabulary, but like some positive elements in there, so they kind of cancel out and then get the result you want. And that then helped me understand that in the whole space rotation, that's why you're enhancing you're basically turning a destructive interference into an actual constructive interference. That's what you're doing, basically. So, and let me pause for a sec. So this is another, I'm back. So this is another idea that I want to try to take a look at. Maybe, here what we're seeing in that particular case is definitely destructive interference. So you're carefully phasing things so that they would interfere. But what about the swaps? Like, I always think about the swaps like, yeah, that's the end effect. That one just goes, that state just goes here, that state just goes here. But do the swaps have like an interference interpretation? Maybe we can quickly, let's just quickly Google that, see if we can find something some clues in here. I'll kind of jump back and forth those two ideas today. So interference interpretation of swap gates. Change time. Because maybe there's no, but experimental realization of swap operation. The minimal number of swap gates. Because quantum computing, if I remember well, here this book also had because there's an actual subgate. For an odd operation, because you can implement that with like 3 control nodes, but swap gate, but I don't know if there's anything that can. Swap gate is 2-qubit operation expressed as in basis 10. Swap gate swaps the state of 2 qubits involved in the operation. I'm not sure if there's a way to take a look at the swap. Maybe I'll ask my quantum tweeter. Hey, quantum tweeter. Hey, quantum tweeter. Is there an interference based interpretation of the swap gate? I'm curious. I'm just tweet. Let's see. What have we got here so far? New followers. Good. Thank you, guys. So swap gate, nothing here. technical implementation. Because okay, but you've got the control swap, so you've got here, as I said, like it's, you can combine those three control nodes like that. But this is awesome, the square root of a swap gate. This is like oh, breaking down the quantum swap gate. Let's see what Craig has to say about it. I think I read this. Swap implemented with 3 C nodes. XOR swapping with Hadamards and control Zs. Okay, so there is sort of an equivalence, right? Because you can, at the end of the day, see it as a control, like sort of combination of control Zs and Hadamard gates. I mean, that's generating XOR swapping into axis swapping. Swap implemented with various axis interactions. Interesting. So you're swapping the y component, the x the y component, the z, the x component, or the z component. Is that it? Interesting. Observable swapping with big observables. XYZ swapping. Simply compute these effects to control not what the specialize in the XYZ swap. I think that's definitely worth reading. Far swap, like fancy swaps. Interesting. Any pair of anti-commuting observables can store a qubit of information. You can use swapping to store and retrieve that information. You remove pieces of a swap. Some access instructions may still switch wires when moving across the swap. Even qubits isolated into different machines can be swapped if you can build up entanglement between the two locations. There's an awful lot to say about such a basic operation. So that's definitely something to go into. Okay, but then maybe I'll try to spend the video on my other so I'll maybe spend the rest of the time trying to play around with these a little bit before, and then my next video is going to be on breaking down the quantum swap. So I'm basically going through that blog post from Craig and trying to understand, trying to kind of get a bit deeper knowledge into the swap operation, and see if there's some kind of like another interpretation to it. So that's definitely square root of a swap gate. Swap gate. That's definitely cool. Then let's see what happens in Twitter as well. But I'll definitely bookmark that, and then okay, let's then start with these. So I'm gonna just start the right away in the most dumb way possible. So, and here's where I'm happy about the flexibility of this editor, is that I can basically, you know, I can basically play with sort of different registers and still get those measurements, like just for the particular register. I think that's then, you know, you kind of ignore that here, but it's helpful. So now I'm gonna try to start. I'm gonna try to kind of basically play around with this. How would you do that without the swaps, right? I'm going to use the. I'm also going to use these. So I'm going to use these to separate the stuff. Good. So first things first. So we want to get there, right? So, and my first thought, which is probably incorrect, is that we should try to flip the operations, but that's probably not gonna, like, you know what I mean? So like these here in the first wire and this in the second wire. That is probably nonsense, but so if I quickly basically do this, no, that's the problem, is I don't want. Okay, so I'm gonna have to. How can I do that? So these things done in tank, because I don't want these things to. I don't want this to happen. I know I shouldn't be using the editor like that. So maybe I should just. Yeah. I think it's gonna make the whole thing less readable, but I'm gonna have to kind of keep them, push them together. I mean, if I do something like that, yeah, it just tends to. Otherwise, it separates the things. Okay, so it's not that useful. But I'm gonna try to basically keep keep those things completely separate. So, so maybe I should just. Can I not make like a? Can I just make a gate that's like the identity gate, kind of. So like these. Oh yeah, but then it's not going to be. It's not going to be expandable, right? Isn't there spacer? I just want sort of a block that does nothing here. Yeah, maybe. Okay. Maybe I'll use that QFT. No. What am I doing? What am I doing? I'll use the spacers. So to indicate that this is the. Yeah, just it's going to be visually easier. Okay. Anyway, so I move this thing here, but then we keep those. Now we also should flip these, right? Because we're also swapping them here. So, so we're basically kind of mirroring this whole thing down. Now, is this? That doesn't look so good. It doesn't really look like that's what's supposed to be. If I put the amplitude display in here, we see that's definitely not the same. The reason being, that, like, if you take a look at, so that's kind of your. That's kind of the initial state for both registers. So obviously the place where you do the Hadamard has an impact, right? So that definitely tells you that you can't just, you can't just do it another way, because this, it seems like the swaps must happen, must be right after the whole thing is done. So it's just, it's obvious. I mean, because you're on computer, it's because you're on computing. But like, why? Mm. I mean, let me just out of curiosity, if I so I'll just move these things here. If I do this, and then I do this, and I do this, and I do this, and I do this. So that's kind of the opposite there. And this is total mess. This is a total mess. Because what we've done is basically like the Hadamard does not act cleanly. Like it leaves a bit of amplitudes in here. Yeah. Because the point is, if you wouldn't do that, like if you wouldn't do those swaps in here, how would I look like? So let's say you don't do the swaps. Crap. Yeah, but then let's say you're flipping, what was it? Can I just do like that and then like get this out of here? Like that. Like that. Like that. So I'm basically swapping now. I think I've done it correctly. But yeah, that's not, because if I don't swap here, if I would, you know, the thing is, because I'm using the QFT, my point is I'm using the QFT, and so that QFT has swaps. So because that QFT has swaps in it, but it doesn't, because at the end of the day, that thing is just the matrix, the transformation. Okay, but it's that particular transformation, but there's another transformation that has the same effect. And so my point here is, okay, so can, wait a second, but how do I, because that, if I look at it from, there's no way that I can, like, this makes kind of no sense at all, because all this is doing is basically doing a Hadamard for every single thing. It's doing a Hadamard for every single thing. And then it's applying these rotations. But maybe those shouldn't change. Because I'm trying to see if, but it doesn't seem to be, this is not like phase. Those things are not, no. 70 degrees, 18, 4, 15, 9, 21. Because if I compare this with so basically all I'm saying is if we're flipping the qubits anyway, isn't it the same than just flipping those things? Isn't it the same like shouldn't it be, that should be the same as just flipping the wires, correct? I mean, that's literally what this means, just flip the wires. Then why doesn't it work? That's a good way to say it. Maybe I oh, but if we flip the wires, then the whole point is, then that should be this. What? No. Because then that goes here. No. That's not right, because you flip after the input, so that should stay like that. But then why isn't it the same? Have I flipped it oh, I should flip it, but like that way. So I should start with these. Okay, is there a way I can move columns? So I should still it should still do this block first, this block afterwards, this block afterwards, I think. So it should still be like, so give me a second, is there in Quirk like how to use, like, I think there's a way that you can column dragging, control key, okay. Cool. So if I drag these all the way here and the Hadamard here, then I drag these. What have I done? These all the way here and the Hadamard here. Then I drag these all the way here. I'll just do it this way, and then I'll just put Hadamard. It's gonna be easier. So if I just do it this way, and then I say Hadamard, Hadamard, Hadamard. I have a touch screen, so I usually forget, and then I don't have a mouse, and that's pretty messy. Why doesn't this work? It's always first should first is with the like that should go this way, and then it's the is the cable. So is the control the one that should be executed first? Because we're flipping the wires, right? Yeah, but that shouldn't technically matter, should it? Whether it's this way or not. That's also not correct. Can I undo? Oh. Okay. That's also not totally correct. I should just that's not totally correct. Quantum Fourier transform. Get rid of these. Get rid of these. So if I get if I no, what was the so this is like that. basically want to swap it with this one, right? This is like that, and I want to swap it with this one. This is like that, and I want to swap it with this one, and then this I swap with this one. So now I've got these. But now, if I do one, what happens? Yeah, but now I should get rid of the swaps, right? Because I've swapped the cables. But I don't get what I want. Then there's something more to the swaps. Why I can't just do that? At least I don't know why I can't just okay, so this looks like it's gonna be the topic for the next video as well. Why I can't just swap? But then maybe I'll get into these. So maybe that's gonna give some clarity. So why can't I just swap the cables? Or am I doing something wrong in here? That's gonna be this. I need to understand a bit more of the swaps, because if that's what I intuitively thought. Okay, swapping means just swap the cables, literally, right? I mean, that's how I even read somewhere. That's how you would go about implementing it physically. You can just swap the qubits, right? But maybe there's some nuance that I'm missing, because that's not what I'm getting here. I'm just doing the swapping wrong. Okay, cool. Anyway, I mean, that's still surprising that, but I really want to make sure that I understand that nuance in here, because it's definitely going to be help me in the future to, you know, break down other algorithms, right? Understanding the phase as interference, and also what's going on with the swap operation. And maybe there is an interference-based. Has anyone answered? Has anyone replied my Twitter comment? I don't know. No. Okay, that's not. Nobody has replied yet. Okay, maybe later. Anyway, thanks for watching, and stay tuned for more.